Okay, well, here we go. Round one of the videos goes like this. Got a couple problems to do, and then I'm going to go through some of the learning targets, and life will be good. So first of all, solving equations review. I can tell the difference between an expression and an equation. Of course, we know that that's because there's an equal sign in an equation, not an expression. I'm going to skip down to solving equations because I think all those other ones are pretty self-explanatory. Solving two-step and multi-step equations are going to be pretty much the same thing. It lists distributive combining like terms and variables on both sides, but I'm going to show you an example here of just a good old equation. This is actually going to be on your quiz, so pay attention to this one if you're watching. If not, you lose. All right, x minus 6x is what? Guest speaker?
X minus 6x is negative 5x.
Negative 5x plus 4 equals negative 11. We subtract 4 from both sides. Negative 5x equals negative 15, and x equals 3. Many time Taney's. Easy enough. All right. Up here, we have order of operations. As always, PEMDAS. Please excuse my dear Aunt Sally. And we write it like that because I don't want to confuse you and make you think that multiplication always comes before division. Either one, as long as we're going from left to right. So here we have 20 over negative 3 minus 7 times 5. So actually this should be times negative 7 times 5. So negative 3 times negative 7 is what? Let's pretend like I didn't write that right there. 21. So we have 20 over 21 times 5. When we're multiplying fractions, we do what? We multiply straight across. 20 times 5 is 100. 21 times 1 is 21. Okay, like I said a million times before, and probably a million times after this, please do not change these to decimals. Leave them fractions and leave them improper. Let's see what else we have. I recognize that when left with an identity statement, the equation has infinitely many solutions or all real numbers. And of course, an identity statement is going to be something like we said that is true, as in like 3 equals 3, x equals x. That means that any real number will satisfy that equation. And above that, we have I recognize that when left with a situation where there is an untrue statement, the equation has no solutions. So if we're left with something like 3 equals 8, obviously that's not true, and so solutions set for that would be no solutions. On the back page, we get down to literal equations, which we talked about today, and absolute value equations. Absolute value equations, remember that if we have an absolute value equation, we're going to always set up two equations. X plus 3 equals 5, and x plus 3 equals negative 5. We subtract 3 from both, and we get x equals 2 and x equals negative 8. Sorry. So always, first we want to get our absolute value by itself, and then we want to set up two equations, solve each of them, and your final answer includes both of those solutions. Do not leave it with just one solution. And remember that if you get 2 for the first one, don't just automatically assume that this is going to be negative 2, because more than often than not, it's not going to be the case. And last but not least, if we have an absolute value equation that equals a negative number, like this, we can stop right there because we know that no matter what value we get inside of this absolute value bracket, it's never going to give us a negative number because this, when we apply these absolute value bars, will make it a positive. So there's no way that any number I put in for x is going to ever give me a negative number. So you don't have to show any work. Just put the null set and life is good.